अभिषेक, अक्षता, आनंद, अंजुम, बसवराज, गडकरी, बसवराज ऐनापुरे, भाग्यश्री, भक्ति,
Present, sir.
ओके, भारती,
Present, sir.
ओके, चेतन कुमार, दीपक, दिव्या, गढ़ प्रथमेश शिवाजी, ज्योति,
Present, sir.
ओके, किरण लिगाडे, लक्ष्मीकांत, मांतेश,
Yes, sir.
ओके, मोळे प्रेम, नागेश, नंदीश, ओके, पूजा,
Present, sir.
ओके, प्रमोद कुमार,
Sir, roll number 22 present, sir.
ओके, हा मार्क, नंदीश है हा मार्क, प्रमोद कुमार, प्रवीण, प्रियंका, संध्या, संतोष, पुजारी, संतोष सोनार, शाहबाज,
Present, sir.
ओके, शफिया,
Present,
श्रीधर,
sir.
ओके, श्रीधर, सृष्टि,
Present, sir.
ओके, सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सुप्रिया,
Present, sir.
ओके, वंदना,
Present, sir.
ओके, वसंत, वेदत्ता, योगेश,
Yes,
महेश,
sir.
ओके, महेश, बाळेश, तैक मोहम्मद, प्रवीण, अभिषेक, ऐश्वर्या, अमानुल्ला, बंडोडकर तनय मोहनदास, भावराव, शोधन, देवाಣ್ಣवर अनिल कुमार शेकप्पा, नंद कुमार, प्रमोद केस्ती, रोहिणी, रोहित अलवाणी, शशिधर, श्रीधर,
Present, sir.
ओके, स्नेहल, वैष्णवी, साईश, कार्तिक, okay, anybody else join? Right. So students, we are discussing about the assignment questions. So we're discussing the 12th question there, right? So factor of a number we discussed yesterday. Write a program to complement the value EAH 800 times. Is it? Complement the value EAH 800 times.
Screen console, sir.
ಒಂದು ನಿಮಿಷಪ್ಪ, ಒಂದು ನಿಮಿಷ. Is it visible now? Is it visible? Yes, sir. So write a program to complement the value AH 800 times. If they are not mentioning it as assembly program or C program, you can write the assembly program. If they are requiring you to write C program, then they'll clearly mention write a C program to complement the value AH 800 times. Otherwise, you can write the assembly program for the
question asked. So you have to complement the value AH 800 times. If we want to complement 800 times, then start with the org. org 0000h. Okay. A small program. First store the value in A register. Move A comma hash AH, right? Then move R2. Here the logic behind this is that now what is the maximum value that we can store in the count? Store the count FFH, that is 255. But they are asking to repeat for 800 times. So what we have to do there? We have to use a loop inside the loop. We have to use two loops. Nested loop has to be used. Loop inside the loop to get 800 times repetition. Correct? Now, so to get that 200 times repetition, what I'm doing is move R2 comma hash 20. Move R2 comma hash 20. Then I'm performing the complement operation, complement A. Okay. Then I will decrement the value in R2 DJNZ, right? R2 DJNZ R2 comma back. Let us see where to put back. Okay. Now R2 comma hash 20 is there. Now if I write only this, I will get only 20 times repetition. So what I will do? Move. I'll use one more register R1 comma hash 40 hash 40. Now the logic behind this program is if I make it repeat 40 times, 40 into 20, 40 into 20, 20 times if I am repeating for 40 times, that will give me 800. Correct? Now to get that, I am loading R1 with 40, R2 register with 20, complement the value in A, decrement R2. Decrement R2 means what will happen here? R2 will decrement from R2 equal to 20 to 19, 20 minus 1, 19, will jump to back. Where this back has to be given? It has to be given to CPLA. It has to come here, CPLA. Again it will come, okay, again decrement R2. So this will be 18, 17, go on decrementing up till 0. Once it has finished 20 times repetition with the value in R2, then I have to decrement the value in R1. BJNZ R1 comma back. R1 comma back. Right? Where this back R1 comma, sorry, up we have to use. Both will be same. Up means where this up should come, it has to load again the value 20. Again it has to load the value 20. Decrement R1. R1 is decremented. R1 will be 40 minus 1, that is 39. 40 minus 1 is 39. Now it is not 0. If it is not 0, it will jump to up. R2 comma 20. R2 is loaded with the value 20. R2 is loaded with the value 20. Again it will perform complement operation. Decrement R2. Again the value of R2 decrements from 19, 18, like this. It goes on up till 0. It goes on up till 0. Next time, once it is 0, it will not jump to back. It will execute the next instruction. Decrement R1. Decrement R1 means, so this goes on 38, right? It is not 0, it will jump to up. Again R2 is loaded with 20. Again complement. Again R2 goes from 20 minus 1, 19, 19 minus 1, 18, like this up till 0. So the inner loop is executing how many times? 20 into 40. Okay, so the inner loop here, it is executing for 20 times. Like that, it is repeating for how many times here? 39, 38, 7. So like this, it goes up to 0. So the inner loop is executing 40 into 20 times. Because CPLA, this repeats for every time it is one step, doing one process, it is repeating for 20 times. Correct? So like this, it is repeating for how many times? 20 into 40 times. 20 into 40 times. So this is performing the repetition of 20 into 40 times, which will give us the repetition of 800 times. Which will give the repetition of 40 into 20, that is 800 times. Got the point here? So this is the logic of the program. So if some questions are asked like this, which are having repetition more than FFH, more than 255, we have to use nested loop. Two loops have to be used, one inside another, nested loop. Then only we can get the values more than 255. Clear here? So 300 R1 comma up. Then next is we have to end the program SJMP $, then end. Okay. So this is the program for performing the complementing the accumulator 800 times with the value AAH. They are asking to complement the value AH 800 times. So like this, some other value may be given. They may give other values and they may ask you to complement, or they may give number of times repetition different. They may not give you 800. They may give some other value and they may ask you to repeat that many number of times. So you have to find out this first. If they ask like that, like how you have found out 40 into 20 is 800. To find out like that, product of that should give the required value, and accordingly you have to use the loop counts here. That is 20 and 40. Got the point here? Is this program clear here, students? This program is clear here? Yes?
Yes, sir.
Okay. Let us move ahead with the next program. Directly, I will come to question number 14. Later, I will explain question number 13 and other questions. So, write a program to multiply 35 by 10 using repeated addition. The question is, question number 14, write a program to multiply 35 by 10 using repeated addition. Save the result in R6, neglect the carry. So they are asking to multiply 35 by 10 using addition method. Okay. Now what is the addition method? Let us see the addition method of multiplication. Suppose say I want to multiply 5 into 4. 5 into 4 is equal to 20. So I can do like this. This is normal way of multiplying. But there is another way of multiplying using repeated addition. Now what I will do in repeated addition? 5 I will add 4 times. This 5 I will add 4 times. That is 5 plus 5. Okay. That plus 5 4 times plus 5. So how much it will give me? 20. Same value that I'm getting with the multiplying 5 into 4. Right? Now the same they are asking to write a program. They are asking to multiply 35 by 10. 35 into 10. This has to be equal to 350. This is equal to 350. So you have to get this value by this method. By this method, addition method, repetitive addition method, not by using MUL instruction. Clear here? A simple program here. Again, we have to repeat using the loop. Start with the org 0000h, org 0000h. Then start initialize the values, move a comma hash 00h, move a comma hash 00h. Then next use the count value. They are asking to perform 10 times. We have to add 35 10 times. What is the meaning of 35 into 10? We are adding 35 10 times. Am I right? We are adding 35 10 times. Move. I'm using a register R2 comma hash 10. R2 comma hash 10. Okay. Then next add with carry a value with 35, a comma hash 35. Now what it will do, this instruction, it will add the value in a register. First we have initialized the value in a register as 0, a comma hash 00h. First instruction, right? That is, it will add the value in a is equal to value in a plus 35 plus carry. If there is any carry, it will consider the carry also. Add with carry. Actually, carry is 0, so it will be 0 only. So this way is nothing but a is 0 first time. We have taken it as 0 plus 35 plus 0. This comes out to 35. Okay. Next. Once we are done with this, we have to decrement the count. DJNZ. I have taken the count in which register? I have taken the count in R2, comma back. DJNZ R2, comma back. So where this back should come? It should come to this instruction back. Okay, back should come to ADDC because it is performing repetitive addition. Next time what it will do, students, it will add value in A is 35 plus 35. Add with carry A comma hash 35. 35 plus 35 plus there is any carry, it has to consider the carry. If it is 0, it will take it as 0. If it is 1, it will take it as 1. So that is 70 we will get. 35 plus 35, 70. Okay. So like this, it will go on adding repeatedly. That 70 plus 35, that is equal to 105. Then 105 plus 35, that is equal to 140. Like this, it will go on adding how many number of times? What is the count we have taken in R2? 10 times. R2 comma hash 10. It is going to add repeatedly 10 times. Dechange R2. First time it will be 9. It is not 0. It will go to back. It will add 35 with the previous value in A. Then decrement R2. It will become 8. Go back. It is not 0. Add previous value in A with again 35. Decrement R2. 8 minus 1, 7. So like this, it will go on repeating up till the value in R2 becomes 0. Then next, what they are asking in the question, they have asked to save the value in some register. See the question, what is being asked. Save the result in R6, neglect the carry. Save the result in R6. The value in A register, we should store it in R6. Move R6, comma A. R6, comma A. Right? Then neglect the carry, not necessary to store the carry. SJMP dollar, SJMP dollar, then end. Okay. So this is a program which is for performing the 35 multiplication 10 using the method of repetitive addition. This is called as repetitive addition method. Performing multiplication of 35 by 10 using the method of repetitive addition. Is this program clear here, students? This program is clear here? Yes? Did you all understand this program? Did you all understand this program here?
Yes, sir.
Fine. So these were the programs, friends. Next is the theory question. Question number 13 is explain the arithmetic instructions of 8051 microcontroller. Explain the arithmetic instructions of 8051 microcontroller. You will have to explain all the arithmetic instructions of 8051 microcontroller. Start with the ADD addition instruction. Its variants, that is add a comma hash data, add a comma at R0, add a comma direct, right? Add a comma direct, then add a comma register, add a comma R1. Okay. Then add with carry ADDC. It's again its variants. ADDC a comma hash data, ADDC a comma at RI, ADDC a comma R1 or RI, then ADDC a comma direct. Okay. The next one, similarly, subtract instruction SUBB, its variants. So you will have to explain considering the byte and the machine cycle. Mention the byte and machine cycle for all the instructions. Okay. Next, SUBB a comma RN, subtract with borrow, SUBB a comma direct, SUBB a comma register, then SUBB a comma at RI. Direct addressing mode, immediate addressing mode, register addressing mode, indirect addressing mode. Okay, all the 4 variants. Then multiplication instruction, MULAB. MULAB, multiplication instruction. The lower byte of the answer is stored in A register, higher byte of the answer is stored in B register. Then DIV instruction, division instruction. Quotient is stored in, after division, quotient is stored in A register, remainder is stored in B register. Then increment, it is also arithmetic instruction, increment byte. Okay, the variants of increment instruction are increment A, increment RN, increment at RI, increment direct. Okay, so these are the variants of increment instruction. Similarly, decrement instruction, DEC byte. Its variants are again immediate addressing mode, DEC, immediate addressing mode is not there here. Increment A, it is called as implied addressing mode. Remember, it is not direct immediate addressing mode. There is one more addressing mode called as implied addressing mode. INCA, it is implied addressing mode. DECA, it is implied addressing mode. Okay. Then DEC-RN, register addressing mode. DEC at RI, indirect addressing mode. DEC direct addressing mode. Then next is increment DPTR. DPTR is a 16-bit register. It will increment the value by 1, 16-bit value by 1 increment DPTR. Then last one is DAA instruction, decimal adjust accumulator after addition. Okay, so these are the various arithmetic instructions of 8051 microcontroller. Okay, DAA instruction is also equally important. Many times it has been asked in examination. Decimal adjust accumulator after addition, DAA. Next is question number 16. Explain the data transfer instructions of 8051 microcontroller. Again here, we have to explain starting with the move instruction, MOV, right? Note that MOV A comma A is invalid. MOV, this instruction is invalid instruction. Move A comma A, this is invalid. We cannot write like this. Okay, and move A comma hash 7F2H. 7F2H. Is it a valid instruction? It is not a valid instruction because the value is more than, here F2 is more than 8 bit. The register can hold maximum 8 bit. The registers in microcontroller can hold maximum 8 bit except DPTR and program counter, which are 16 bit registers, which can hold 16 bit values, right? Rest of the all the registers can hold only 8 bit values. So this instruction is invalid again because it is storing more than 8 values. It is not possible to store more than 8 bit value in a register in 8051 microcontroller except in the DPTR and program counter registers. Okay, so you have to explain all the data transfer instructions of 8051 starting with the move instruction, that is immediate addressing mode, move A comma hash data, move A comma RN, then move A comma direct, move A comma at RI. Next is take RN to the destination side, move RN comma A, move next move direct comma A, move at RI comma A. Just reverse them. Move A comma RN is there, reverse it, move RN comma A. That is also valid instruction. Then move A comma direct is there, make it move direct comma A. That is also valid. Move A comma at RI is there, move at RI comma A. Right? Then in move RN comma A, again there are variants. Move RN comma hash immediate data, move RN comma A, move RN comma direct. Okay. Then again in move direct comma A, there are variants. Move direct comma hash data, move direct comma at RI, move direct comma register, then move direct comma A. Okay. Then next move at RI comma A. Again there are variants in move at RI comma A. That is move at RI comma hash data, move at RI comma A, move at RI comma direct. Just you have to interchange there and accordingly you have to study there. Okay. So these are few of the move instructions. And other move instructions are move destination bit comma source bit, single bit instruction, move P1.2 comma C, move C comma P2.5. Okay, then move DPTR comma hash 16 bit value, move DPTR comma hash 16 bit value, right? Then move X A comma at DPTR or move X at DPTR comma A. That is also data transfer instructions only. Then move C A comma at A plus DPTR, move code at A plus DPTR, move C A comma at A plus PC, move C A comma at A plus PC, move X A comma at DPTR, move X at DPTR comma A. Just interchange them. Similarly, move X A comma data transfer instruction, push instruction, because it is pushing the value, it is moving the value. Push direct, push memory location value, then pop direct, pop the memory location value. Then exchange instruction, XCH A comma byte, XCH A comma byte. It will exchange the value in A register with the value in the register. XCH A comma RN, XCH A comma direct, XCH A comma at RI. Okay, various variants of the exchange instruction, XCH A comma RN, XCH A comma at RI, and XCH A comma direct. Last instruction in the data transfer instruction is XCHD A comma at RI. So many times this instruction has also been asked in the examination. XCHD A comma at RI, XCHD A comma at RI. This instruction will exchange only the lower nibble of the value in A register with the lower nibble of the value in RI register. Okay, so it will exchange only the lower nibble of the value in A register with the value lower nibble of the value in memory location in register R0 or R1. XCHD A comma at Ri. Only the lower nibbles will be exchanged. Suppose in A register we are having 42 and in B register we are having 46. Then it will exchange 2 and 6. A register will get 46. Then Ri register R0 or R1 memory location that will get 42. Only the lower nibbles, lower 4 digits will be exchanged with the instruction XCHD A comma at Ri. Okay. So is it clear here, students? Any doubts here? So we have solved with all the assignment questions. Any doubts here? So whenever you are writing the program, remember, first you have to know the logic. It may be any program, maybe this programs, whatever we have solved, or it may be any programs that may be asked in a test or in examination, right? We have to know the logic. According to the logic, you have to write the instructions. So that will become your program. Okay, so they are all logic based. Whatever programs are asked in the microcontroller subject, they are logic based programs. So you all have to know the logic. Once you know the logic, immediately you can transfer it in the form of instructions, and that will give you your program. Okay. So they are all logic based programs that are there in the microcontroller subject. Okay. So you have to think a little bit. If some question is asked, if some program is asked, you have to think a little bit. Think upon that. What may be the logic of this? Just think for a while. Take few minutes to think, right? And then try to know the logic of that. What is being asked? What I have to do? What I am supposed to find? Where I have to store the data? From which register or which memory location I have to get the data? Which instruction I have to use? Which addressing modes I have to use? You have to give a little thought. You have to think a little bit, and then accordingly, based on your logic, what you have developed, according to that logic, you write in the form of instructions that will give you your program. Is it clear here, students? Any doubts here, students? Any doubts here? Students, any doubts? Was it understood? Bhakti?
Yes, sir. Understood.
Understood? Okay. Bharti? Bharti? Jyoti?
Yes, sir. Understood, sir.
Fine. Lakshmikant? Mantesh?
Yes, sir. Clear,
Mantesh?
sir.
Any doubts, Mantesh?
No, sir.
Okay. Nandish?
Yes, sir.
Nandish?
Understood.
Okay. Pooja? Pooja?
Yes, sir. Understood, sir.
Okay. Fine. Shabaz? Shabaz?
Yes, sir. Understood. Understood, sir.
Okay. Shafia? Shafia? Any questions,
Yes, sir,
Shafia?
understood. Sir, no.
Any questions? Okay. Supriya?
Yes, sir. Understood.
Okay. Vandana? Vandana? Yogesh? Yogesh? Sridhar? Sridhar?
No
Sridhar?
doubt, sir.
Okay, fine. So that's all then. Do well. Okay. Wish you all the best. Right. Do the test well and wish you all the best. Okay.